So we have the function g of x, which is equal to 2 over x to the third minus 1 over x squared. And what I want to do in this video is I want to figure out what g prime of x is. And then I also want to evaluate that at x equals 2. So I want to figure that out. And I also want to figure out what does that evaluate to when x is equal to 2. So what is the slope of the tangent line to the graph of g when x is equal to 2? And like always, pause this video and see if you can work this out on your own before I work through it with you. And I'll give you some hints. All you really need to do is apply the power rule, a little bit of basic exponent properties, and some basic derivative properties to be able to do this. All right, now let's just do this together, and I'll just rewrite it. G of x is equal to this first term here, 2 over x to the third. Well, that could be rewritten as 2 times x to the negative 3. We know that 1 over x to the n is the same thing as x to the negative n. So I just rewrote it, and now this might be ringing a bell of how the power rule might be useful. And then we have minus, well, 1 over x squared, that is the same thing as x to the negative 2. And so this, if we're going to take the derivative of both sides of this, let's do that. Derivative with respect to x dx. We're going to do that on the left-hand side. We're also going to do it on the right-hand side. Well, on the left-hand side, the derivative with respect to x of g of x, we can write that as g prime of x is going to be equal to, well, the derivative of this first, what we have right here written in green, this is going to be, we're just going to apply the power rule. We're going to take our exponent, multiply it by our coefficient out front. Actually, let me write that out. So that's going to be, let me finish this equal sign. That is going to be 2 times negative 3 times x. And now we're going to decrement this exponent. You have to be very careful here because sometimes your brain might say, okay, 1 less than 3 is 2. So maybe this is x to the negative 2. But remember, you're going down. So if you're at negative 3 and you subtract 1, we're going to go to the negative 3 minus 1 power. Well, that's going to take us to negative 4. So this is x to the negative 4 power. So 2 times negative 3 x to the negative 4, or we could have also written that as negative 6 x to the negative 4 power. And then minus, well, we're going to do the same thing again right over here. We take this negative 2, multiply it times the coefficient that's implicitly here. You could say there's a 1 there, so negative 2 times 1. So you have the negative 2 there. And then you have the x to the, well, what's negative 2 minus 1? Well, that's negative 3 to the negative 3 power. And so we can rewrite all of this business as the derivative g prime of x is equal to negative 6 x to the negative 4th. And now we're subtracting a negative, so we could just write this as plus 2x to the negative 3. This negative cancels out with that negative. Subtract a negative, the same thing as adding the positive. So we did the first part. We can express g prime of x as a function of x. Now let's just evaluate what g prime of 2 is. So g prime of 2 is going to be equal to negative 6 times 2 to the negative 4th power plus 2 times 2 to the negative 3rd power. Well, what's this going to be? This is equal to negative 6 over 2 to the 4th plus 2 over 2 to the 3rd, which is equal to negative 6 over 2 to the 4th is 16 plus 2 over 2 to the 3rd is 8. And so let's see, this is, we could rewrite this. Let's write all of this with the common denominator. I could write this as 1/4, but then this one won't work out as cleanly. I could write them both as 8s. This is negative 3/8, negative 3/8. So you have negative 3/8 plus 2/8 is equal to negative 1/8. So the slope of the tangent line at x equals 2 to the graph y equals g of x has a slope, or that slope is negative 1/8.